All right, good. So let's now look at more proofs. We have proof that if ABC are angles of a triangle, then tan A plus B plus C is equal to tan A plus tan B plus tan C minus tan A tan B tan C, 1 minus tan A tan B minus tan A tan C minus tan B tan C, like that. Then hence also, hence deduce. You can say hence deduce that tan A plus tan B plus tan C is also equal to that. Okay, good. Let's step in for it. Now they want tan A, they want us to expand this out, say, from, they want us to show that this is true from left hand side. I'll start from a tan of A plus B plus C. Now what I'm going to do, I will say, let, since our expansion is, the expansions we know about tan is the one which is in this format, A plus B, when you have only two angles. But here we have three angles. So what you're going to do, we shall say that, all right, let the A plus B equal to M. Let A plus B equal to M. And that will imply that a tan of M plus C. You can see that logic. I've finished to let it. So now we'll come and expand this, whereby I'm having it 2. So this will be now tan M plus C will be equal to, right, tan M plus tan C. I'm using the normal expansions of tan over, this will now be over 1 minus tan M tan C. That's what you're having now. In the next level, I want now to put back my M, such that now that will be tan, but my M was A plus B. I put it back, tan A plus B, this level, plus tan C over 1 minus tan A plus B. I now bring it back, times a tan C. All right. Now that means that we have again to re-expand this one. So that will be, right. So this will now be, expand this level here. That means that this level alone means a tan A plus tan B over 1 minus tan A tan B, like that, plus just tan C there. Please, I've expanded this and it has given me this. So I will say, maybe to make some fraction, you can say over 1, so that they can all correlate. Then also down, it will be 1 minus a tan, okay, this needs to be in bracket, 1 minus tan A plus tan B over 1 minus, I'm expanding only this, tan A tan B, like that. And this will be times that tan C which we have there. By default, we have that tan C. The next, what you're going to do is, let's solve this one up using the LCM. And LCM, I want to solve this one up. The numerator, sorry, this one. Its LCM will be what? The LCM for that, the LCM of this and this will just be a 1 minus a tan, a 1 minus tan A tan B. If you can see that, the LCM for that. Now, I want to understand the meaning, okay? Maybe I can first of all do with this. Now, this LCM, I'm solving only up. This is what I'm doing. You can forget about what is down. Now I'm solving this. Now, the LCM divided by this is 1. This divided by this is 1 times this to remain that very stuff, which is a tan A plus a tan B. Then from there, this 1 minus tan A tan B divided by 1 remains that very stuff times this. So that will be plus, now the tan C multiplying with what has remained for the other part, which is 1 minus tan A, okay, tan B. That's what I'm having. Good. That's what I'm having. Good. So I want to now proceed. I will say divide by, what are we going to have? Now also down. Divide by, the LCM here is this, and once you divide it by that, it will just be that. So the LCM is the same. Now why am I dividing? It's because I've finished the one for up. Now this one here means divide. This one means divide, and I'm simplifying it in that way. So I'm now coming to this one, which is down. Now realize that this time is multiplying up, no problem. So this, take it as a fraction also. This divided by this times that, it will be, after there it will be a 1 minus tan A tan B. Okay. Minus, oh, I think I would have just put it direct. I'm sorry. The spaces ain't enough, so allow me put it here. Allow me just, now I want to divide this, but I want to put it to make it a bit unique. That division symbol separating the one up and down. That division symbol, okay. I can bring on this. That will be this divide the LCM. Now the LCM for down is also this. The LCM is 1 minus tan A tan B. That's what I'm using. Now when you divide this by 1, it remains times that. So we shall still have a 1 minus tan A tan B minus, now this other guy. This divided by this remains that. So that will be a tan C into tan A plus tan B. Tan A plus tan B. Like that. Okay, good. Now, at this level, what you must know is this one is similar to that, and they cancel to give us 1, 1. They are similar to that, and they cancel to give us all right, 1, 1. They cancel to give us 1, 1. Now, what you're going to begin with is, okay, in simple terms, what I want us to see is, because some people will not see what I'm meaning here. This one is A, and this one is B. And this one is A, and okay, this one is X, and this one is Y. What I'm doing is, this is A over B divided by, I want to see this logic, divided by X over Y. Now, division, solve those fractions. So A over B, O over B, then this one also, that over B, because they are similar. Because this one I'm taking it to be A over B, then here X over B. So that will be X over B, like that. That's what you're doing there. Now this will be that A over B. Now you multiply times, you get a reciprocal, B over X. So this and this cancels. Meaning that at the end, we shall have A over X. So therefore, it will just remain as, okay, this one up. Or even after cancelling like this, you can see that you take this over this. So that will be, okay, tan A plus tan B plus tan, okay, tan C, I'm expanding here, okay, plus tan C minus tan A, tan B, tan C. What I've done is I'm multiplying this times this times that. So the arrangement tan C over, this will be 1 minus a tan A, tan B, minus, multiply there, it will be tan C, or it can just be tan A tan C. It is multiplication, tan A tan C. Then also, this times this is this times this will be plus tan B tan C. As simple as that. Anything more? Let's see. What do they want as per the proof? Oh, like we are. I think we already have the proof at hand. This is equal to that, like we are. So we can now say, for that level, it is quite easily done. We have finished it. It has come out. But you have to be steady with the steps. It is a bit bulky and very, very examinable. Some people think that hard questions can't be set. Please, it can be set, and it's not even hard. Okay. All right, now let's go to hence part. Hence part, they want us to deduce that tan A plus tan B plus tan C is equal to tan A, tan B, tan C. Now, in the deduction of this always comes from if they say for A, B, C are angles of a triangle. Whenever you see that statement in trigonometry, then just know you must use this fact that for any triangle, when we add the three angles, the total sum we get is 180. That's what you get. So, hence part. So A plus B plus C is equal to 180. Now what you do? What do we have? We have almost tan everywhere. So what we do? You introduce tan on both sides of this. So introducing tan on both sides, that will be tan A plus B plus C will be equal to tan 180. Now what does it mean? But do you have the expansion for tan A plus B plus C? Yes. You have it as this. It is there. So therefore you come and bring it forward. You come and say, now tan A plus tan B plus tan C minus tan A, tan B, tan C over 1 minus tan A, tan C minus tan B, tan A, tan B, then tan A, tan C, and then plus, okay, plus tan B, tan C is equal to, now is equal to, remember, this is for this, now is equal to tan 180. When you try to press tan 180, tan 180 gives you what? A 0. Tan 180 gives you a 0. Now when you put over 1 to be a fraction, you can now cross multiply. This multiplies with that, and this multiplies with that. To begin with, this times 1 will remain that very fact. It will just remain, and that will be a tan A plus a tan B plus a tan C minus tan A, tan B, tan C is equal to, now you see that here, this denominator times 0. Anything times 0 remains a 0. So that will just give us a 0. Like that. Then what you do, where's our deduction? Our deduction is tan A plus tan B plus C is equal to, okay. So you can take this, the other side. So now that will now be a tan A plus a tan B plus a tan C. This is equal to tan A, tan B, tan C. As simple as that. It's a block question. They can give it 12 marks, section B. And that's how simple it is. All right, thank you. Don't forget, please. It takes just 1 second to do that. All right, good. Let's proceed. We have another question there. They're saying that prove that the angle theta between the straight line y is equal to m1x plus c1 and y is equal to m2x plus c2 is given by tan inverse of m2 minus m1 1 plus over 1 plus m1 times m2. This is a simple proof, and it was also examined in UNEB 2019 section B. They brought a number on that part. Then also some number appeared in the 1990s there, but of course some people are not okay with such years. However, in 2019 they examined them on this part. Okay. So now we want to see how we can prove this. So let's prove that the angle between the two straight lines, the angle between the two straight lines. Now what we begin with is, we shall imagine if, say for example, we have a Cartesian plane. We have a Cartesian plane like that, this being our x-axis, and this being our y-axis. If you have a Cartesian plane like that, let's imagine these are two There are two straight lines. The angle between two straight lines means that we must draw two straight lines but with an angle somewhere. That's our aim. So I'll draw like this, anything like that, such that these angles, these two straight lines make an angle. Say, for example, an angle theta at that level. Or by the way, they even told us angle theta. They are making an angle at a certain point they are meeting. Because I said they prove that the angle theta between straight line this and the other. So the angle theta is that. Okay, good. Now having done that, you know that vertically opposite angles, if this one is theta, even in here we shall have that as what? Theta. All right, so what are we going to do now? You realize that now, let's see. Which angles are these lines making with this x-axis? Remember, these are positive angles. Positive angles means that we're going to measure them from that line moving this side anti-clockwise. So we need this angle like that. Then we also need this angle like that. Please don't again put here. No, that is wrong. It should be in that order. Now, what I'm going to do, I will call this one here. All right, maybe this angle here, I will call it alpha for my case. And this other one, I will call it angle beta. Angle beta, like that. That's what I've decided to use. Okay, now, having done that, the angle outside, this one here, outside, will be the line, this other line, the line this side, here, should be the line correlating with this first value. Take note. The one outside here should correlate with this first value. Therefore, this should be your line 2. This should be your line y is equal to m2x plus c2. Take note, this one with an angle protruding from outside like this is one you name to be having that m2 or any other value which starts from here. They can even use lambda. They can use lambda 1, lambda 2. The one with the 2, this 2 thing here must be the one which appears first here. We have numerator, denominator. The one which appears first here is what you name this to be. So that's the line. This one is the line y is equal to m1x plus c1. So that's what I'm having. Now next, what are we going to do? We shall pick it from the fact that if this is a triangle, see? You see that this an angle inside an angle. You see that the sum of two interior angles is equal to one opposite exterior angle. So it's have that sum of two interior angles is equal to sum of one opposite exterior angle. I'll write like that. Now the sum of two interior angles are where? This plus that. So therefore, the alpha plus theta will be equal to beta, like that. But what they want us to get is the angle theta. They want us to find the angle theta. So make angle theta the subject. So mathematically, this will be that theta is now equal to that beta minus alpha. After doing that, let's now see as per the proof. The proof has tan. So therefore, you also introduce tan. So therefore, introduce tan on both sides, that beta and theta is equal to a tan of beta minus alpha. Okay, so proceeding, this will be expand. That now be tan beta minus tan alpha over 1 minus tan beta tan alpha, like that. Now, having reached that level, what are we going to do? Now, I think that this one is resembling this. We have this minus that. Then you see this and that. So what we do? We can say let m2 equal to tan beta, comma, then m1. Of course, why? Is because the one beginning here is this. And this one here is that let tan alpha equal to m1. Now let's substitute. Substituting, we shall have tan theta is equal to, all right, equal to m2 minus m1 over 1 minus m2 times m1. There we are. But what they have here? They have a tan inverse, meaning that they made theta the subject. So making theta the subject, theta will be equal to, can now write there and say tan inverse of m2 minus m1, like that, over 1 minus. Now here you can change the order. Since it's multiplication, you can stick to this. That's now m1, m2. It is multiplication, no problem. Like that. And I think it has been successfully done. So you say quite easily done. You go and please check for that number you name 219 and see, relate it with this solution. And that is very, very simple. Forget not, subscribe.